time here. And thanks to everybody for joining. Very, very much appreciate it. As you can see, I have a very long, like Fiona Apple album level title here. Reality is, I want to talk about building in a very, very real way. And I think that's really important for everybody to acknowledge that at the end of the day, let me just get going, you're going to make mistakes. No matter how hard you try, no matter how well prepared you are, you're going to make mistakes. And that's absolutely okay. There's nothing wrong with that. Some of these mistakes you probably could have seen coming in retrospect. Some of them you had no ability whatsoever to avoid. They were just unpredictable, some of the crazy chaos that we deal with every day in the AWS Cloud. And part of that reason is simply just the vast number of services and features we have in the AWS Cloud. I think anybody who's been building in the cloud for more than a year knows that we're about to hit the mother load at the end of November 30th. AWS reInvent 2020 kicks off online, and we're going to get just an absolute flood of new services. In fact, that normally starts 3 weeks ahead of reInvent. And, the reality is you cannot keep up. It is the vast majority of my job to try to keep up, and it's just crazy impossible. And that's part of the wonderful part of the AWS Cloud. We're always getting new features. We're always getting new services. And that just means there's so much complexity, there's so much possibility that you're probably going to make mistakes. And that, like I said, is absolutely okay. The problem is, especially for those of us who work in large organizations, is that kind of leads naturally into what we like to call best practices. Now, personal opinion here, side rant, which is most of this talk. I'm not quite at Corey Quinn's level of ranting and snark, but I'm aspiring. I hate with a passion the term best practice, because it implies that there's only one way to do it. It implies that this is the way you should be doing whatever you're trying to accomplish. And I don't think that's true. I think there's a multitude of ways to do it. And really what you're missing there is context. Why is this the best solution for this circumstance? That's really key here, for this circumstance, because all the time you have different circumstances, you have different challenges. If you were lucky enough to tune into Zamira's talk just before this one, she was explaining that, she has customers who have a couple accounts, a couple dozen accounts to hundreds of accounts. And if you're dealing with account management, each solution you're going to pick is going to be different based on the context. So there's no true best practice. There's what's well for now. And that really leads to the main thrust of this talk, which is the AWS well-architected framework. Hit me up in the chat. Let me know if you're familiar with the framework, and hopefully you're applying its principles. This is a collection of knowledge, of wisdom that is hard won. It is built over the years from AWS customers. Tens of thousands of AWS customers have contributed, the AWS ProServe team, solutions architects, and the community at large. And it is a wicked, awesome, amazing repository of knowledge that really is trying to teach you some core principles. But you may have noticed in the AWS console, there is actually the well-architected tool. You're seeing it right here. And if you dive in, this is security section, question 4. You'll notice that it gives you this prompt. It says, configure service and application logging. Now, that sounds a lot like a best practice. And you could consider this a best practice, but here's why I don't like that term again. I told you I was going to get ranty. The reason I don't like that is because what are you going to do after you turn all this on? Yes, it's a fantastic idea to turn on CloudTrail, CloudWatch, GuardDuty, and Security Hub. But what are you going to do when CloudWatch generates an alert? How are you going to react to that? What is your team going to do to handle that information? Same with if you see a finding out of GuardDuty or Security Hub, what are you going to do with that information? What's the next step? What's the context in which you're going to use that? Because it's one thing not to have these on. That's bad. It's another, to turn them on and then not be able to do anything with the information. I think that's worse, because my experience, I'm a security guy at heart. My experience in security, it's easier to say we didn't have the capability of seeing that issue before it happened than to go to your board and say, well, we had an alert sitting in our inbox that told us exactly what was going on, but we didn't do anything with it because we didn't know how. That to me feels worse. So the idea here is to drive around some core principles. And each of these principles are aligned to one of the 5 framework pillars. So we have operational excellence, cost optimization, reliability, performance efficiency, and security. Now, each of these have their own dedicated white paper within the framework. There's an overview paper and then a deeper dive into each one of these pillars. But don't think for a minute that they're separate. They're actually completely intertwined. You can't have one without the other. You can't have security without reliability. You can't have operational excellence without diving into cost optimization and performance. And as much as you want all of everything, right? I want an easy to run, super cheap, amazingly reliable, performant, and secure solution. You're never going to get there. That's just the reality. You're going to have to keep evolving and changing. And that really brings us to the core of the framework. And those are the principles. So there's 6 principles here. And the first one is use on-demand resources whenever possible. So idle is your enemy. You don't want stuff that you're paying for that's not actually working for you. You want to make sure that everything's automated. If you're typing it in, it better darn well be into a script to automate it the next time and not to actually make a change, because then you're just not moving yourself forward. You're not improving your daily work. You need to test regularly and at scale. And you're going to see an example of that in the story I'm about to tell you. And if you've ever dealt with AWS, they're data obsessed, right? And that's because they've really taken to heart, this principle about fact-based feedback loops. And the idea here is that you have a really quick way to tell if what you're doing is worth doing. Really that simple. And of course, that leads to constantly evolving your architecture and practicing. So it was implied in what I told you earlier of having the alerts. What are you going to do with them, right? And if something falls over, how are you going to pick it back up? So these are the 6 principles. Principles around the well-architected framework. And they're really about teaching your team how to constantly question and improve and move forward. Nothing is stagnant in the cloud. But before I get to the story, I really want to underline this. We are doing a blameless postmortem here. I'm not going to mention the specific team or the company they work for. We're not going to judge. They made decisions that made sense at the time, given their circumstance. And I think this is a really key element of DevOps philosophy. It was brought up in the Phoenix project and reinforced in the Unicorn project by Gene Kim, both fantastic books. And this idea is, let's look at the work and let's learn from it and move forward instead of casting judgment. So this team was building a streaming video platform. They started last year when the pandemic hit and things started shutting down. And they were looking to fill a very specific niche. They wanted to sell access to these streams. And none of the big platforms met their needs for cost, for privacy, or to tailor what their small team could deliver. So they needed a custom solution. Now, this isn't crazy. It's pretty straightforward of a design. And this is, sort of what they were aiming for when it comes to the end user. We've seen this 1,000 times. You can slap any number of logos on here. You've essentially got a web browser that's delivering live video, and you've got a side panel that's delivering live chat. So authenticated users come in, they can watch the stream, they can chat about it. I don't know, kind of like we're doing right now, right? Very, very similar. It wasn't this platform, though, just as a caveat. I won't name the names, but I'll tell you who it wasn't. It wasn't this one. So this is the setup, and this is the design they came up with. So the users would access an application load balancer that would hit just one big pool of EC2 instances that were in a scaling group that were running this custom app. That app pulled from S3, and it made transactions back and forth with DocumentDB, which is the MongoDB repository, or MongoDB compatible repository run by AWS. And of course, they were using CloudWatch to monitor it all. This is a pretty solid solution. There's nothing here that you kind of go like, oh, what are you doing? This makes sense, especially when you think of, this is a couple people. This is 2 to 3 people who were building and running this. So they've simplified it out to optimize what they can actually deliver to their users. Now, the challenge here is, of course, is that video and chat are running on the same instance pool. You can probably see where this is going, but we're going to walk through it anyway because it's worth learning the lessons. They had metrics around the request response time, sort of end to end for the user in seconds. And when they were running their tests, anywhere between 10 to 50, and I've normalized out the graph to make it easier to get the point across, anywhere 10 to 50 users, they were seeing really great performance, right? They were having somewhere between 1 to 2.5 seconds for a user to get up and running on the platform, which is not bad. That's a tolerable experience. It's into that zone that the Nielsen Norman Group, who are fantastic UX researchers, say is, you notice that you're waiting as a computer, but it's acceptable. If you can go sub-second, then it's imperceptible to the user, and it's just a much more pleasant experience. But over a second is not too bad as long as, you're keeping under this 2.5 second. So as they started, they ran their tests. They said, great. They sold tickets to their first event. And as that event started to spin up, they noticed they got way more than the 50 people. Now, here here's where the first fall down happened, is that they sold tickets, so they should have known how many people were coming. That's a direct correlation, right? You sell 100 tickets, you can expect 100 people. But what they didn't expect was the day of the event, sales really shot up, and they were so busy getting ready, they never actually went back and checked that, because sales was another part of the team, somebody else's responsibility. So as they start to roll this out, they see over 100 people are there, and they start to see a spike in response time. We're getting closer to the average of 2.5 seconds instead of like 1. Well, that's a problem. Well, this event was amazingly popular, which is a great business problem to have. But when they got to 1,000 users, things started to get really bad. 10 seconds on average for response time. Now, I don't know about you, but the last time I waited 10 seconds for a web page to load was probably 1995. Right? Like, just not something we're used to in this day and age, with ubiquitous bandwidth and great speeds. So 10 seconds, users started complaining, they started dropping off, they started abandoning the stream, even though they had paid for it, and of course, they were really grumpy. And as the users continued to spike in and stream into this, to get access to this stream, things just got out of control. It got into this really odd loop where their auto-scaling metrics weren't great. So as the demand requests came in and spiked up, they would spin up more instances, but then those requests would be abandoned, and the auto-scaling group was trying to scale them back down again. And so they got stuck in this bad place, and nothing was responding, and the whole thing essentially tanked, and they were scrambling, trying to figure out how to serve their users. So they did not test regularly at scale. They tested, which was great, but they only tested with sort of less than 50 people, which they thought would be reasonable. Like, hey, look, this scales. It should scale the same way on up. That's what auto scaling is for. But they didn't realize they needed to pre-warn this if they had spikes in demand, that this kind of thing would happen. So this is a problem. And it reveals the fact that they never practiced what would happen if things died. They were scrambling to make a status page. They were trying to reach people on Twitter. Just in general, not great. So if we look back through the idea of the lens of the framework, we see operational cost was pretty low, or operational excellence was pretty low. The cost was solid because it was tied to actually paying users. Not at all reliable, not at all performant. And the security was okay, because they just had that one set of instances to monitor and to lock down, to do patches and upgrades and things like that. So not bad. But they knew they had to do better because it wasn't a successful stream. So they split. That's the first thing they did. They split their chat and they split their video. They used the same app. They just didn't use half of it. And they used the ALB to route video to one and chat to the other. And this made a huge improvement. Simply diverging concerns made a big improvement. Now, the problem they still had with the video scaling up, but people were able to actually log into the chat. They saw the interface. They were able to complain, and complain they did, in the chat about how bad this was, but at least it wasn't completely just a crash screen and throwing out errors left and right. But it still wasn't good enough, right? So this was a good evolution, but it was just one step along a path that they needed to be taking. So what they realized when they had split this, well, hey, wait a minute, do we really even need EC2 instances to serve out the video? And it turns out, of course, they didn't. They have another EC2 instance that the streamer was actually streaming to, but they could drop that instead of into a pool of EC2 instances to serve out. They could drop it into an S3 bucket and use Amazon CloudFront in order to push that out to the users. And now they've got a really slick solution because it's far less overhead for operations, and it actually turns out to be less cost. So they've evolved the architecture, which is great. They've moved away from having these instances run it. And I would argue here that even though they were using on-demand EC2 instances, they've actually taken that principle of using on-demand resources to the next level. So instead of paying for EC2 instances that are only used 70% of the time, for CloudFront, they're being billed for every gig that's going out, which directly ties to a user that's being served, which directly ties to a ticket that was purchased. So that's a really good use of the new architecture. So here we see operation stays about the same because they still have some instances to manage, but cost is improved, reliability is improved, performance is improved, security is about the same. So let's keep going down this path. They realize, hey, wait a minute, breaking this apart is really, really useful. We're seeing some huge advantages to breaking this system apart. And so they went even further. And they realized that chat app doesn't actually have to run on EC2 instances. Turns out that AWS has sort of a jumpstart in an example project on the blog that shows how to deliver a web chat through AWS Lambda functions and AWS AppSync tying back to a DynamoDB table. So here we've gone to a full serverless solution to deliver the chat part of their application. In fact, they've moved this entire solution inadvertently into a serverless solution, which has greatly reduced their overhead and has made it a lot easier for them to scale and a lot easier for them to make sure that it's running and keeping the lights on. So they evolved the architecture yet again, right? This is our fourth or fifth evolution, and they're getting closer and closer to a solution that best fits their needs. Now, they are currently exploring going even further, which is crazy. And they are looking at the new Amazon Interactive Video Service. This service dropped earlier in the fall. And essentially what it is under the hood, it's a CloudFront and an Amazon S3 and a few other things stitched together. But from a user perspective, from a builder perspective, you push video into an endpoint that you've built, and then the SDK gets dropped into your app and delivers that video to your users. So they've taken even the little bit of overhead they had with CloudFront and that S3 bucket and eliminated that. So all they have is the interactive video service, fired up an endpoint pushing there, and that makes the solution even slicker for them. That's a great principle. We're following the principle of automating all the things, right? They've gotten rid of even more of their operational burden. So operational excellence is through the roof. Cost optimization is great. It's reliable. It's performant. It's more secure because they've gotten rid of those instances. Remember, if you have an instance or a container, you need to patch it. You need to update it. You need to constantly monitor it for a variety of security issues. But if you're running a completely serverless solution, that's AWS's problem, which is a wonderful thing to hold on to. So if we compare that to where we originally were with the solution, we've made strides in all 5 of the pillars, right? This is a great work by the team. Through constant evolution, they've made strides in all 5 of the pillars and come with a much better solution for their users and for their business. This is a huge win. So what are our takeaways here? What's the key to figuring out how this works, right? Because isn't this just what we all do anyway? Well, kind of, but there's a little more formalization around it. We're using the framework to help guide us through here, because the AWS well-architected framework is really about finding the best solution for you at the current time. So if you see someone come out of an AWS well-architected review, which is something you can do with an APN partner or on your own, and they're like, we passed our review, we're well-architected. Yeah, for now. But something's going to change, and if it's you changing it, you know about that. But we know reInvent's coming, and there's a whole bunch of changes coming from AWS. You are going to have a different answer to what's well architected tomorrow than you did today. In fact, that's one of my absolute favorite parts of AWS reInvent, is that something that I will have this, what I think is a lovely, elegant hack of, 50 lines sitting in a Lambda to solve a problem is now a checkbox after reInvent, which is great. And that's the idea of the well-architected framework, is you keep finding the best solution for any point in time. You continually evolve forward. We do that by applying those 6 core principles of the framework itself. It's not a list of best practices. Despite your impression of the AWS well-architected tool, that tool is a prompt to help you apply these principles. And the principles are using on-demand resources whenever possible. So we want to make sure that we're not paying for idle time. We don't want to spin up stuff just to have it sitting there in case we need to use it. This is why serverless solutions are such a great fit. And when you're looking to design a solution, you should start with serverless, go to containers if you have to, go to instances if you absolutely must, because you want to apply this principle of using on-demand resources, and that applies throughout the entire AWS cloud. Similarly, automate everything. Don't do things by hand unless you're just testing out the proof. And as you're doing that by hand, create the automation as you go. You should not be doing things by hand at this point, because it's just so much easier to automate it. Almost everything's available through an API or a CLI command. Take advantage of that. That makes testing regularly and at scale very, very easy. You have relatively, essentially infinite capacity in the cloud. Take advantage of it by testing a real duplicate of your production environment to make sure that if it's going to blow up, you know how it's going to blow up. If it's going to fail at a certain level, you know, because you've tested it in an isolated way and not impacted your users. And again, this concept that we keep hitting on, feedback loops that are data-driven. So you have an idea, you set up some metrics around it, you test it out, and you learn from that. And that creates this constant evolution of your architectures. And as you're evolving, don't forget about that operational piece. Understand how this thing works in practice, how you're going to use it, how you're going to have processes around responding to alerts, responding to issues. And so that's not all bad. That's just working through, right? Professional football teams don't just take the pitch. They practice too. You are just like that. You need to practice and work it through. Remember, the framework's organized around these 5 pillars. They work together. They're not isolated. You need to make sure that they work together to have a solid solution, but it's really at its core. It's this constant idea of having an idea, trying it out, learning from it, adjusting and repeating, and just keep on going, because that's how you're going to learn. That's how you're going to evolve and get a far better architecture than when you started out with, just like we've seen in this example for the video streaming platform. Thank you very much. My name is Mark Nunninkhoven. I'm an AWS community hero. I'm also the vice president of cloud research at cybersecurity leader Trend Micro. You can hit me up online at marknca or at my website, markn.ca. And I think we still have a little bit of time for questions. So Zamira, is there any questions kicking around?
Yeah, thank you so much, Mark. It was a really nice presentation about well-architected framework and all the 6 pillars I really enjoyed. So how you can really start to have a well-architecture and well-designed when you start, especially with new in AWS and when you really don't have experience. So let me see. I don't see any question. However, I have myself a question for you.
Okay.
So, Mark, I'm really curious why would I want to use the AWS well-architected framework? Let's say, what really the advantages of using this framework instead of, for example, probably I have a best solution architect in my team or in my company. Why am I going to use this tool? So what does this tool help me?
Yeah. And so there's two parts to that. There's the framework itself, which is some documentation, some white papers that help you apply the principles and understand the principles. Then there's the actual well-architected tool. And a lot of people go into that tool in the console thinking like, this is gonna, I'm gonna point it at my CloudFormation template and it's gonna verify that I'm following all these good ideas. And really what the well-architected tool is a way to have a discussion with your team. And I like how you phrase that because a lot of teams do fall back on that sort of that one person who's like, oh, you know your stuff, we're going to come to you all the time. And that's okay at the start. But really what you want to do is you want to increase everybody's cloud fluency. That's a term that Forrest Brazil uses from A Cloud Guru all the time. And I love it, so I'm stealing it. You want to make sure that everybody is increasing their knowledge of the cloud and everybody is increasing their knowledge of what makes a well-architected solution, because then you're going to all move forward as a team. Right. And I really think of it in that team, in that sports metaphor, if you want, where you can't just have one person on a football team who's doing everything, because that doesn't work. You're up against a whole nother team. The whole team has to be at the same level, working together. And so the well-architected framework gives you that guidance of how to think and how to move forward under those principles. The tool itself in the AWS Management Console is basically just like a Git repo of discussion results. So as you go through and actually type in your answers, it will version it. And so you can tie it to the versions of your code and say, for version 1, here's the discussion we had. And we skipped this, we didn't do this. We thought about this, we moved here. Then for version 2, you keep going.
Right?
Yeah.
Okay, a really good answer. So it was very useful. And I have another question as well. How can teams start using a well-architected framework? So where is this tool? How they can start using?
Yeah, so if you just go to, if you search for well-architected in AWS, you'll land on the main page. It's, aws.amazon.com/well-architected. And right there, the first thing to do is read the overview paper. It's only 6 or 7 pages, and it really just introduces the pillars. It introduces some of the principles and the ideas behind the framework. And then it's really just, I find it best used as a tool to start talking. So if we were working together, Zamira, I would say, okay, I looked at what I built, and I find like, while it, it seems to perform really well, there's so many things I need to do behind the scenes to make that happen. That's not really efficient from a performance perspective. So we're not getting that performance efficiency pillar in there. What can we do to move forward? And so it's really just a discussion starter. It's not a magic wand. I wish it was, but it's a way to help talk to each other on the same page using the same terms to move your solution forward.
Yeah, wow, this is really good answer. Thank you. And I'm very curious, and I have another question, Mark. Sorry for that, but I'm very curious. For well-architected framework, this tool is good, let's say, to be used only for enterprise company or for startup company, when this can be more useful?
I would say everyone. And because it is just about talking and thinking about how you build, I've found it useful for 3 or 4 person teams, which is what the example I was using in my talk. I've taught enterprise teams with hundreds of architects and hundreds of builders the same thing. So it's really not about the size of your shop. If you're building anything in the AWS cloud using any number of services, this is a really useful tool. And it's really about teaching that principles, because I think the biggest tragedy in the cloud, if I may, is when people just assume like, oh yeah, I know how to do this, I'm just going to do what I've always done. And you're leaving a lot of power and a lot of things that help you on the table and unused. So it's good for anybody and everybody who's building in AWS.
Yeah, definitely. I am. I'm definitely. It's important to have always or to start it always with in a good solution, because when you do mistake in the beginning, you have to pay in the end.
Yep.
It was my example as well. So thank you so much, Mark.
Thank
And
you.